If we remember from class, frequency or the frequency of a wave is essentially the number of waves that you will see for a given amount of time. So if you notice up here, 50 is not the actual frequency. This does not signify a frequency of 50 hertz. As I increase the frequency, again, frequency is number of waves, essentially. So as I increase the frequency, you will see more waves for the same given amount of time. And if I decrease the frequency, you will see fewer waves for the same given amount of time. So the first important thing to realize is frequency is essentially the number of waves that you will see in a given amount of time. That's kind of your general definition. Now, a more technical definition is the number of cycles or the number of complete waves that occur over a given amount of time. And that's where our frequency equals cycles divided by time equation comes from. So as you notice here, if you look, we're not getting very many waves for a given amount of time. So frequency is really the number of waves per second or the number of vibrations per second. So given 1 second here, you'll notice we don't have too many waves. We probably don't even have one full wave per second. If I increase my frequency, I'm increasing the number of cycles, so I will have more complete cycles or more complete waves in a given second. So how do we actually calculate this? Well, again, we can't assume that this is the actual hertz, the actual frequency that this vibrates at. But if we remember that frequency is just very simply the number of cycles or the number of complete waves for a given amount of time, we should realize that we need two things. We need the number of cycles, which we can fairly easily count by determining how many times this goes up and down. As you can see, every time it goes up and down, it produces one wave. We also need time. So what we can do here is if we pause this to slow it down, I'm going to get this green dot back to its equilibrium point. So every time it goes up, down, and returns back to its equilibrium point, that would be one complete cycle. I want the amount of time for one complete cycle. It's going to be a little bit harder if we try and measure just one, so I'm going to measure 10 cycles and then divide the number of cycles by the amount of time. Cycles per time is frequency. So if I start my timer, it won't start because time is paused, but I'm going to unpause this and I'm going to calculate, I'm going to determine 10 cycles here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I should probably go a little bit more. 10 cycles would be right back here. So this has now gone up, down, and returned one complete cycle 10 times. So my cycles are 10. The number of time, or the amount of time that's passed, is 5.55. Frequency is very simply the number of cycles, 10, divided by the amount of time, 5.55 seconds. So the frequency of this wave right now is about 1.8 hertz. That's how frequent these waves are occurring. Every second that passes, about 1.8 waves, almost 2 waves, will have occurred. So just to show you again, if I increase my frequency, again, this does not mean 70 hertz or 71 hertz. What you wind up getting here is a much higher frequency, so you wind up seeing more waves for the same given amount of time. So again, if I want to measure this, I'll return this green dot to the equilibrium point. I'll restart and start my timer. So I'm going to measure 10 complete cycles. Down, up, and returning would be 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a little bit more than 10, but it's close enough, so I'm going to assume that that was 10 cycles. So we clear this, 10 cycles divided by 3.97. Cycles over time will give me frequency. As you can see, my frequency was 1.8 before. It's now about 2.52. I slid the frequency slider from 50 to 71, so my frequency should have increased, and in fact it has. So just realize if you'd like to calculate frequency, you must know the complete number of cycles and the time over which those cycles have occurred. Higher frequency, essentially more waves. Lower frequency, fewer waves for the same given amount of time.